Okay, folks, so get the agenda copied down real quick. And then go ahead and get this copied down real quick. So folks, today we're introducing probably the most important concept there is when it comes to electrical theory, and that's Ohm's law. Ohm's law, I think that if you understand Ohm's law and you know how to use a meter, there's not going to be a whole lot of stuff out there that you can't troubleshoot and find faults in as far as electrical circuits go. So Ohm's law is a key. Now, we've learned all this time that electronics and electrical theory is all about controlling current flow, the movement of electrons. So it's all about controlling current. And the things that we've learned is we've learned that there are really two ways of controlling current. I got the force behind the current that makes it go, and I've got the force in front of the current that actually slows it down. The force that makes it go is called voltage, and the force that slows it down is called resistance. Now, the reason Ohm's law is so important is because Ohm's law states those relationships between voltage, current, and resistance. A lot of people will say that Ohm's law is a formula. Well, Ohm's law is not a formula. There is a formula that actually proves everything that Ohm's law says, but Ohm's law itself is not a formula. Ohm's law is actually the statements of relationship between voltage, current, and resistance. So this is what we have to talk about first. Since it's all about controlling current, and there's only two ways to control current, well, we have to understand the relationships between these three. All right, so the first statement in Ohm's law is that voltage and resistance are directly proportional. Voltage and current are directly proportional. Voltage and current are directly proportional. The second statement in Ohm's law states that voltage and resistance are directly proportional. And then it states that current and resistance are inversely proportional. Now we've got these statements, and we have to realize that these statements all end with the same three words. Stays the same. You have to understand that voltage and current are only directly proportional if resistance stays the same. And that voltage and resistance are directly proportional if current stays the same. And the third one, the current and resistance are directly proportional or inversely proportional if voltage stays the same. So really the relationships are between two of the variables, and it only holds true if that third variable is held constant or it stays the same. So let's talk about this. The best way to get this concept down is to think about something that we already understand. And that's keeping the speed in a vehicle that we're driving. And we got two pedals down there on the floor. We got an accelerator and we have a brake pedal. Now, if we think about the movement of the car as current flow, the movement of electrons, and we think about the accelerator, the force that makes it go, as voltage, and we think about resistance as the brake, the force that slows it down, it kind of helps make sense a little bit. So let's talk about this first relationship. It says that voltage and current are directly proportional. Okay, so directly and proportional. Just two new words that we have to understand. Well, think about this. If voltage were the accelerator and current was the speed, if I increase the accelerator, what's going to happen to the speed? Well, it's going to increase. So if I increase the accelerator, the speed goes up, and if I decrease the accelerator, the speed goes down. So we have this relationship where both variables are moving in the same direction. An increase, increase, decrease, decrease. This is called a direct relationship when both variables move in the same direction. So directly means they're simply moving in the same direction. What does that word proportional mean? Proportional. Well, everybody says by the same amount, but proportionality is about the same percentages. Meaning that if I take this and cut this in half, this also will be cut in half. No matter what the values are. This could be 5 going to, or this could be 10 going to 5. This could be 2 going to 1, but they're still both cut in half. If I double one, I double the other. That's proportionality. It's changed by the same percentage. So voltage and current, the force that makes it go and the go are directly proportional. They're going to move twice. If I double one, the other one's going to double. If I cut one in half, the other one's going to cut in half. This is a directly proportional relationship. All right, so we got voltage, current, resistance. The next statement says that if voltage and resistance are directly proportional if current stays the same. The other one was voltage and current if resistance stays the same. Now this is voltage and resistance if current stays the same. Well, I want you to think about something. The brakes are not the only thing that will slow a car down. You think about going up a hill. Well, we don't have too many hills up here, but you think about going up a bridge. When you go up the bridge, in order to keep going the same speed, you have to add accelerator. Or you're going to slow down because that bridge is in opposition to your go. So you have to add accelerator to keep the same at the same speed, or the current and speed at the same speed. So if I'm going up a hill, or if I'm going straight, I got my accelerator, but if I start going up the hill, that adds opposition. I got to add voltage. I got to add accelerator to keep that speed the same. So the more opposition I have, the more force I got to have to make it go to keep the go the constant amount. Okay? So voltage and resistance are directly proportional. If my hill's twice as big, I need twice the accelerator in order to get up that hill at the same speed. And vice versa. If I'm going downhill, well, I'll let off the accelerator. Because I have less opposition, I need less accelerator to keep going the same speed. So voltage and resistance are directly proportional if current stays the same. So the last one is the relationship between resistance and current. Now this is speed and brake. If I increase my brake, that's going to decrease my speed. If I increase my brake, that's going to decrease my speed. If I decrease my brake, that's going to increase my speed. So now I have this relationship where the variables are moving in opposite directions. This is called an inverse relationship. When the variables move in opposite directions, this is an inverse relationship. And it is also proportional. If I double the opposition, I'm going to cut the flow in half. If I have half of the football team defense out there, my offense is going to run all over them, make all kinds of movement on the field. But if I double up my number of defense and put 22 people out there instead of 11, now that offense is hardly going to be able to move at all. The more opposition, the less flow. The less opposition, the more flow. This is an inverse relationship, like the one we have for voltage, or for current and resistance. Now you might be asking yourself, well, how are you going to test this on air? Are you going to make us? No, I'm not going to make you write that word for word. What's the point in that? So here's the deal. This is how I'm going to test you on this. Okay, copy those down real quick. So if you look at these questions, and we're thinking, okay, so okay, so to answer these questions, it might be difficult because there's some words up there you're not really totally familiar with, and that's voltage, current, and resistance. But if you take 2 minutes and think about this right here, that's all you have to do. Accelerator, voltage, speed, current, brake, resistance, they make totally good sense because you understand these relationships. So if we just take a minute and swap out these words, these are going to make total sense. So for example, if the current through a resistor increases, the voltage across that resistor will. Well, think about it. If the speed down the road increased, the accelerator had to, increase. The second one, if the resistance in the circuit decreases, the current in that circuit will. Well, if we read it like this, if the brakes are let off down the road, what will happen to the speed? It increases. That's exactly right. And the last one here, if the voltage in the circuit decreases, the current in that circuit will. Well, if we read it like, well, if the accelerator is let off, the speed will decrease. If the voltage decreases, well, the current will decrease. Okay? Now, something else I want to show you, just one little, well, I can't just yet. So I'm going to get back to that. Actually, this wraps up the little section on the concept of what Ohm's law is, the importance of it, understanding the variables and the words of directly and inversely proportional. So next thing we're going to cover is the formula. So the formula is actually going to help us prove out some of this stuff. So we'll be back in a second, folks. Hang on to that. And